Alright, so here we're going to learn another rule to do derivatives exactly. Alright, and this is we're going to learn how to do the derivative of the ln of x. And so this may not have been something we looked at before, but let's look at the graph of what ln of x looks like. Ln of x actually looks like this. It kind of goes down towards negative infinity as it approaches x equals 0. And it always does increase, but it increases really slowly out here. So let's get a little bit of intuition for what the graph might look like. The graph of the derivative might look like, that is. So if we wanted to come here and look at some of the tangent lines, so let's look at the tangent lines of ln of x. If we look at a tangent line of a point close to 0, we can see that the slope of this tangent line, here maybe, is very, very positive, right? It's really high. It's up here, right? And if we look at the slope of the tangent line at a place more like x equals 1, we can see that, oh yeah, it's still positive, but not nearly as positive. So like at x equals 1, maybe it has a slope of 1, right? So x equals 1, the slope of the tangent line is 1. And out here, the tangent line is very close to 0, right? It's not a very steep tangent line, so it's something like that. So with these 3 points, we can see that the graph of the derivative is going to look something like that, right? And so that's actually what the formula tells us. The formula tells us that the derivative of ln of x is equal to 1 over x, right? So this is really the graph. What we're graphing out is 1 over x. And so let's use that to answer this question. Find the slope of the tangent line to f of x equals 2 times the ln of x at x equals 1 and at x equals 5. So to do that, we're going to want to find, the first thing we're going to want to find is the derivative. And we have a constant here, 2, times something that we know how to take the derivative of, right? So what we're going to get is 2 times that thing in the times the derivative of the thing in the brackets. So f prime of x is going to be equal to 2 divided by x. Now if we want to find the slope of the tangent line at point 1, kind of the slope of this line that I was drawing here, we would plug in point 1 into f prime. So f prime of point 1 is equal to 2 divided by point 1, which if you work this out, you will get this is equal to 20. So a very, very strong positive slope. Now, if we do something like f prime of 5, we have to plug in, so we're finding the slope of the tangent line at 5, so kind of like the slope of this tangent line here. We have to plug in 5 into our derivative, so 2 divided by 5, which is equal to 0.4. So again, a pretty low derivative, right? The slope isn't that great. So let's practice using this rule in some more complicated situations. So here we have a few different functions. We have find the derivative of x to the 5th minus the ln of x. So the derivative of x to the 5th, we know this from the power rule from the last section. So we drop the 5 down. We'll do 5x to the 5 minus 1. And the derivative of ln of x, all we have to do is just look at this formula. Derivative of ln of x is just 1 over x. So I'll write that there. And then if I want to simplify this, this is really 5x to the 4th minus 1 over x. Let's look at this one over here. So this is one where, again, I have a constant times something that I know how to take the derivative of. So it's going to be 11 times the derivative of what's inside here. So 11 times 1 over x. Same thing I did right here. And then I'm going to have minus, and this is an e to the kx thing, right? And so if you remember that formula from earlier, the derivative of e to the kx was equal to k, so we'd have a 0.2 times e to the kx, right? So if I want to simplify this, maybe write it a little bit nicer, I would write out 11 over x minus 0.2 e to the 0.2 x. So big idea from this section, from this video, the derivative of ln of x is just 1 over x.